Hello and welcome. This is going to be our lecture video for the week of October 27th. Go ahead, get out this piece of paper, hand it out in class. If you didn't get one, it's available on the extra stuff calendar, or you can just copy this onto a blank piece of paper and clip it into your step-by-step binder. Go ahead, put your name on there, whatever date you're taking these notes, and your period number and your cohort. All right, let's get started. So, types of solutions. Normally we just get one solution when we're solving, but there's other options. So we're going to go over some of these unique cases, these special cases today, other things that can happen. But when you start solving a problem, you won't know that it's a special case until you're almost done solving it. So step one is going to be solve the equation using inverse operations and the balancing method. Solve the equation using inverse operations and the balancing method. This is what we would normally do if we were faced with an equation. Step two, if you can isolate the variable with a number on the other side, then that is your answer. If you can isolate the variable with a number on the other side, then that is your answer. This problem has one solution. But in step three, if while solving all of the variables cancel and you are left with a true statement, and let's write down some examples of true statements like 1 equals 1, 2 equals 2, 3 equals 3, 79 equals 79, anything like this. If, while solving, all the variables cancel and you're left with a true statement, like a balanced equation with the same number on both sides, then the equation has infinite solutions. So you write infinite solutions. Or x equals this fancy r with an extra line through the middle. That stands for all real numbers. When solving linear equations, when this happens, it means that our variable is equal to every single number, or every single number could be the value of the variable and the equation would still be true. It's another way to think about it. All right, and there is another option, step 4. If all variables cancel, and you are left with a false statement, the equation has no solution. I mean, letters are mixed up there. So we're going to write no solution. Or x equals, and it's this fancy crossed out circle that means null. It's like there's no actual value. Be careful, when we get x equals 0, 0 is just a number that counts as a situation with one solution. This is a no solution. All right. Let's solve some and see what we get. So problem number 1. I don't see parentheses. I don't see like terms on the same side. I do see variables on both sides, so I'm look to combine them. Normally you move the smaller one, but they're the same size, so I cross out both x's, and I'm left with 10 equals 6. So all my variables went away. Is this a true or a false statement? Well, 10 equals 6 is false. So maybe we should have written some examples here. Like 1 equals 2. All right, and so we check, what should I say? I should say no solution. You can just write it just like that and move on. Okay, let's try this next one. So no parentheses, no like terms, so I look to move my like terms on opposite sides. The negative 4m is smaller, so I add that to both sides, and now I'm left with 4 equals m plus 4. Negative 3m plus 4m is just m. We got constants on both sides, so I want to move away from the variable, so I'll subtract 4 from both sides. And I'm left with 0 equals m. This does not count as a no solution. This just is the answer. M equals 0. Put a box around it. This is not the same as no solution. All right, number 3. No parentheses, but I do have like terms. I want to combine those. So I've got negative 2v equals negative 2v. I'll add 2v to both sides to bring these like terms together. And I'm left with 0 equals 0. Well, is that true or false? 0 equals 0 is a true statement. So we want to say v here equals all real numbers. So you do the fancy R with an extra line right through the middle. It's called a double struck R. That stands for all real numbers, and we can box that. V equals all real numbers. All right. So this was an infinite solution situation. Let's see what this last one is. I want to get my variables together, so I subtract 6m from both sides. I'm left with 1 equals 7, and that is a no solution. 1 equals 7 is false. 1 does not equal 7. No solution. So it's hard to test all real numbers and no solutions. So you just have to be really solid with your math. If you do get just one answer, you can always plug it back in to double check. So m equals 0, I plug in a 0 here and a 0 here, I get 4 equals 4, the equation balances. All right, there are 2 more on the back side. Let's try them together real quick. So I do have parentheses, so I want to distribute to get rid of those parentheses. I have to distribute on both sides. When I distribute, I multiply. So we get 24 plus 30x plus x equals 12x plus 24. Combine my like terms with the 30x and the x, but at the same time I want to subtract 24 from both sides. And I get 31x equals 12x. So I should subtract 12x from both sides. To bring those together, this is now a 19x equals 0. Divide both sides by 19. This is an x equals 0. We can plug it back in to double check. So that would be 24 equals 24. Yep, it checks out. All right, last one with number 6. I've got parentheses, so I got to distribute. All right, I've got like terms that I'm going to combine, the 25 and the 1. So now I've got negative 20r plus 26 equals negative 10 minus 20r. Got variables on both sides, so I look to combine them. I'm going to add 20r to both sides. And I get 26 equals negative 10. All the variables have canceled, and I'm left with a false statement. So what do I say? No solution. All right, that's that for this lecture video. I'll embed a few more questions here, and have a good rest of your day.